Woohoo! I'm back. Hey everybody. I wanted to go over looking at Lewis dots diagrams and how to make those. So I just went over the Bohr models. Now I want to go over Lewis dots. So let's do a couple examples here. First one, let's do one that's under 8. So let's do let's do one that's under 4. So let's do something like, say, uh, calcium. So if we follow our instructions from our assignment here or our reading, it says find your element on your periodic table. So calcium's right here, it's number 20. I'm gonna open up Paint again and I'm gonna write that down. It's gonna be the center of our diagram. So the symbol is Ca, calcium. And then what we have to do is I have an optional step that says lightly sketch a plus symbol over the top of your other symbol. So what that means is something like this. So like if you lightly penciled it in, it would just go over the symbol, just a plus sign like that. And understand what I'm saying here? So it would just be straight lines back and forth to kind of show you each side of your symbol. All this is trying to do is show you that each symbol has 4 sides, and we want to use those 4 sides to our advantage to break up our diagram. Okay, that sounds confusing, but I promise it'll make it's easy. So we did that optional step. If you understand that each of your symbols has 4 sides, you don't need to do this step. This is only for the people who need help, like organizing their diagram. So the next thing we have to do is look at the column in which your element is in. So we see that calcium is in column number 2, and it says in here if the column is 1, 2, 13 through 18. If it's one of those, you have a definite number based on that column number. Okay, so it's in column 2, which means it has 2 valence electrons. Here, I'll show you how this whole thing works without you having to memorize this. Look at your table. Column 1 has 1 valence electron for each. Column 2 has 2 valence electrons apiece. That skips to 13. 13 has 3. 14 has 4. 15 has 5. 16, 6, 17, 7, and 18 has 8. Notice for 13 through 18, you just have to take the 1 off, and that's how many valence electrons it has. Now, you're wondering, what about all these guys, the transition metals in between? Those have variable numbers of valence electrons, and they don't always have the same number all the time like our other columns. That's why these columns 1, 2, 13 through 18 are lifted up on the periodic table. The ones that are lifted up are the important ones with the set number of valence electrons all the time. Okay, so calcium has 2 valence electrons. Okay, so if we go back here, we found out how many it has. Then what you want to do is draw the corresponding amount of dots around your symbol. It says starting from the top and going around clockwise, placing 1 dot at each side of your symbol until you have 4. Okay? Well, calcium, it's not so hard because calcium, starting at the top and going round, 1, 2. Calcium only has 2, so this is what calcium's Lewis dot diagram looks like. Okay? I don't have any more to add around it, so that's what it is. Okay, let's do another one. Let's do one that is over 4. Or like that is 4. Let's do carbon. Carbon is in row 14, so it has 4 valence electrons, or the 4 electrons in the very last orbit, or its last energy shell. So we put down our symbol C, capital C. And I'm not going to draw my cross because I already know that I have 4 separate sides on my symbol here. And it says add your dots starting at the top and going around clockwise until you have 4. 1, 2, 3, 4. 1 at each side. Mine are a little offset, so I can actually do that different if you want. 1, 2, 3, 4. I have 1 on each side. I don't have any more to add. This is the diagram, the dot diagram for carbon. Let's do, let's do iodine. Okay, go over here again, write in my symbol, just iodine. I came out a little bigger than the other ones, that's okay. And where is it? Which column? It is in column number 17, which means it has 7 valence electrons. So we go back to it, go back here, and we do 7. Notice on my directions it says until you have 4. After that, continue around by adding a pair dot to each dot until you reach the final number of valence electrons. This just means keep going around in a clockwise pattern until you have 7. So 1, 2, 3, 4, 5, 6, 7. Making sure to pair your dots together and not do a continuous circle. The reason you don't want to do a continuous circle is because counting in pairs makes it easier to keep track of how many valence electrons you have. So this right away you can go, there's 3 pairs, that's 6 plus 1 is 7. Or it's easier to count 2, 4, 6, 7. Okay. Let's do one last one. Let's do one over here. Let's do radon. Okay, radon over here. Is Rn. It is in row 8 or column 18, which means it has 8 valence electrons. So we go back there and we start at the top, going around in clockwise order. 1, 2, 3, 4, 5, 6, 7, 8. Making sure to pair my electrons. Remember, they should be a little bit easier, like more lined up. It's hard to control my mouse, so but in any case, this is what a valence, like a Lewis dot of radon would look like. So you just go around making sure you do it that way. And that the thing about going around in a clockwise pattern isn't such a big deal now, but I want you to get into the habit of doing that because in chemistry, it's a big deal when it comes to knowing how a whole molecule, when you start putting these like things together, how your molecule is shaped. Okay, but right now, if you don't, you know, going in a clockwise pattern is a good practice. It's not hugely important for you guys right now, but in chemistry, if you take it, it will be. Okay, so that is Lewis dot structures or Lewis dot diagrams and how they work. Yeah. If you need more help on those, let me know. They're fairly easy. It's just the number of the, the last shell of electrons around your symbol instead of all of the electrons instead. Okay? All right. I'm going to end it there. And if you have other questions, let me know. Bye, everybody.